We are going to look at transversals and angles created by transversals and relationships that we can find with those angles. A transversal is a line that crosses two other lines at two distinct points. So here's an example. That's a line. It crosses these other two lines, right? And it crosses them at these distinct points, right? One point and another. So if the line crossed those two lines but only in a single point, that would not count as a transversal. It has to be two distinct points. When a transversal crosses two lines, it always creates a bunch of angles. And you can see here we have a bunch of numbered angles right here, right? 1 through 8. You always get those 8 angles. And we can pair those angles up into pairs that have special relationships, and we give them names. So the first we have listed here is alternate interior. The word alternate comes from the fact that alternate interior angles, like for example 1 and 2 as are listed, are on alternate sides of the transversal. They're on opposite sides of the transversal. So that's the word alternate. The word interior comes from the idea that they are both between the two lines that the transversal crosses. 3 and 4 are also alternate interior angles. A different pair of angles would be 1 and 4, which are, instead of being on opposite sides of the transversal, they are on the same side of the transversal, but they're still in between the two lines that the transversal crosses, so we call them same side interior. 3 and 2 are also same side interior. I'll get to corresponding in a minute. First, I'm going to talk about alternate exterior. Like alternate interior angles, alternate exterior angles like 5 and 8 are on different sides of the transversal. But they're not between the two lines that the transversal crosses. They're outside. They're each outside. And so we call them alternate exterior. And likewise, 5 and 7 are on the same side of the transversal, but they are also exterior. So same side, exterior. We have alternate interior, same side interior, alternate exterior, and same side exterior. And then we have corresponding angles. Clean this up a little bit, and so I can mark it up some more. And then we'll talk about corresponding angles. The best way to describe corresponding angles is that they are sort of pointing in the same direction, okay? And it's important to note that for all of these pairs we're talking about, the alternate interior, same side interior, all of these, whenever we have a pair of angles, we're talking about a pair of angles that's uniquely created by transversals. So one angle is on one intersection, kind of up here, right? And the other angle is on the other intersection, down there. So when we have corresponding angles, we're talking about angles that sort of point in the same direction, one from each intersection. So for example, angle 1 and angle 7 are on each of these two intersections, these two distinct points that the transversal makes with the other two lines. They both face down and to the right. Okay, angle 1 and angle 7. They're sort of going in the same direction. Okay, whereas 3 and 8, right, are going to the bottom right, of each of their intersection. Or you can think of it as like southeast and southwest and that type of thing. Angle 2 and angle 6 are corresponding. They're both going to the top right, and angles 4 and 5 are going top left. So those are corresponding angles. And that's all of our 5 pairs, special pairs of angles that are created by a transversal. Alternate interior, same side interior, corresponding, alternate exterior, and same side exterior. They don't have any specific relationship as far as their measures unless a particular feature is true of your figures. In these cases, there's nothing we can necessarily say about these pairs of angles. But if I go to the next page here, we get a drawing, get a new figure, and we have some features here. These little triangles, okay, tell us that the lines are parallel. And when we have parallel lines, then our angle pairs that are created by the transversal have special relationships. The first one that we need to talk about is corresponding angles. When, and we have, you see we have a bunch of statements here, the first one being corresponding, but all of these statements start with the same little part. They all start with the fact that the lines that the transversal crosses are parallel. So they all say, if a transversal crosses parallel lines, then the corresponding angles are congruent. That's how that one goes, and they each continue from that same point there. If a transversal crosses parallel lines, and our first one is that corresponding angles are congruent. This fact is a postulate, which means that it's just something that we accept. It's something that everybody sort of agrees on, and it sort of just follows from the nature of parallel lines. The corresponding angles are going to be congruent. It's just sort of a feature of parallel lines. So we consider it a postulate, something that's basically obvious or something that we all just sort of agree on. It's a convention. Then what we can do is take that fact and use it to prove these next four facts that I'm going to explain in a second here. That if we have parallel lines, there's some more relationships. So we'll use this postulate about corresponding angles and use it to prove these next several relationships. And I'll do a video later, another video with an example of one of those proofs. And these facts that we're going to prove are that if the transversal crosses parallel lines, that alternate interior angles are also congruent. Exterior angles are also congruent. Same side interior angles are supplementary. So their measures add to 180. And same with same side exterior angles. They are also supplementary. So their measures add to 180. So let's use these facts to find the measures of these numbered angles in our figure. Okay, and we'll start with measure of angle 1. And what I like to do is you can recopy, if you're working out of a book, you can recopy the figure or whatever. And I like to just highlight the angles that I'm working with. So first I'll find the measure of angle 1. And I'm going to compare it to the angle that has a measure of 50 that was given, and see what relationship they have, and use that relationship to find the measure. I can see that these two angles that I'm talking about are on line C. They're both on line C. Line C makes up part of each of these angles. So C, therefore, is the transversal, okay, because it's the line that they have in common. And C crosses A and B are, of course, parallel. I can see that angle 1 and the angle that has a measure of 50 are both on the same side of the transversal. But they're not both interior and they're not both exterior. But so they can't be same side interior or same side exterior. But angle 1 faces down and to the right, and so does the angle with measure 50. So that makes them corresponding. Okay? So that means that their measures are congruent. So that means measure of angle 1 equals 50 degrees. Okay? And I can justify that by just saying that they're corresponding angles. I can abbreviate, and that's my justification. I'm basically alluding to the postulate that we just talked about, where corresponding angles are congruent. Now let's see if I can find the measure of angle 2. So I'm going to clean up my drawing a little bit, and you can recopy yours if you need to. Okay, that looks better. Measure of angle, we want to find measure of angle 2. Angle 2 is right here. Okay, and again we have this 50-degree angle. You can see that both of these angles are on line A. Okay, so that's the transversal, and A crosses lines C and D, which are parallel. These two angles we're talking about and that we're looking at are both on the same side of each other, of line A. They're both on the same side of line A, the transversal. And they're both in between lines C and D, which makes them same side interior. And that means that they are supplementary. So that means measure of angle 2 plus 50 equals 180. And I can justify that because they are same side interior angles. So I'll just note same side interior. If I was doing a proof, that would be my justification. And I subtract 50 from both sides, and I get measure of angle 2 equals 130. Okay, degrees. And of course, you can justify that with subtraction property if you needed to. Well, now, if I look at this picture, everything else kind of just falls into place. I can use a lot of other relationships I know. For example, I found angle 1, it was 50, and 5 and 1 are vertical. So that means angle 5 is 50. Let's see, 2 and 3 are corresponding, which means 3 is also 130. And 3 and 4 are vertical, so 4 is 130. So I've gotten all the angles on the bottom. Let's see, 8 is vertical with the 50-degree angle, so it's 50. Angle 6 is alternate interior with 50, so it is also 50. And 2 is alternate interior with 7, so 7 is 130, and that covers all of our angles. And so we're done. And that is how we deal with angles formed by transversals, and especially with parallel lines. See you next time.